All right, everybody, this is 12.2. Last time we talked about two types of angles. We talked about central angles, where the angles are at the center. We talked about inscribed angles. I'm going to look at an example of that, where we have the angle is on the circle. And then today we're talking about circumscribed angles, and that is where the angles are outside of the circle. So there's these three different types. This is the third and the final type of angles that we'll be covering. All right, so let's start with a little bit of vocab that we haven't covered yet. First is called a tangent line, or a tangent. It's a straight line that intersects the circle one time at one point, okay? And that point is called the point of tangency. All right, and then we also have secants, okay? A secant line is also a line, but instead of touching the circle one time, it will cross it two times. Okay? And if these two arrows continued going, eventually they would cross and that would make an angle. And so that's like the type of angles that we're going to be trying to find. One thing that you can be aware of is that when you have a tangent, its radius is always perpendicular to that tangent line. All right. So now that we've talked about tangents and secants, we can talk about these types of problems where we have a tangent and a secant where the vertex is on the circle. So we've already talked about when we've had angles on the circle. Again, that's called inscribed. So inscribed angle. And we also know the relationship between those. So what we wrote down was 2 times the inscribed angle is equal to the arc. That's just what we did last time for the second half of our lesson. And if you need to go the opposite direction, well, we could divide both sides by 2 and we'd get the inscribed angle is equal to 1/2 the arc. So depending on which way what they're asking you for, you may want to use either of those directions. But they're the same equation, they're just solved a little differently. So here if we're trying to find x, and we know the arc is 120, well then we can use that relationship and we can say that x is half of 120, which is 60 degrees. Okay, so again, this isn't like the new type of angle that we're covering today. It's more like what we did before. Has the same rules that we covered before. It's just now we have a tangent line, so this is like B, maybe we can continue that. BC would be the tangent line, and it has a point of tangency, and then we also have this secant line that crosses the circle twice. All right, so keep that in mind. This is just another example of inscribed angles. All right, so now we also are just some more examples of that. If you want to pause and give these a try, I think that would be beneficial for you. All right, so here we have our arc. That's what's given, and they want us to find the angle. So again, the relationship is if you have the arc and you need to find the angle, we divide it by 2. So 76 divided by 2, and that should give us 38 degrees. And this is kind of going the opposite direction. We have the angle, we need the arc, so we would do 80 times 2, which is 160 degrees. Okay? And then here, this one's a little tricky. It's a little different. Okay, we want to find that angle. There's kind of 2 ways you could go around to do this. Is we could take that arc of 220 and then we could find this arc because we know that a circle adds to 360. So we could do, oh, that was weird. We could do 360 minus 220, and that gives us what? 140. So that would be our arc, would be 140, and then if we need to find the angle, again it's half of that, so this would be 70. So that's one way you could do it. Other people I've taken this arc and they said, well, then this angle has to be half of this, so this has to be 110. And then we have a or like a straight angle, right? So that's 180. So we could do 180 minus 110, and that would give you the 70. So there's different ways to come about doing it, but both are good. Take about the same amount of time. All right, so this is the other type of angle, the third type of angle, the circumscribed angle. It's where the angles are outside of the circle. Okay, it can be made three different ways. You could have two secants. All right, so each of them cross the circle twice. We have the angle, which is outside of the circle. And then we need to talk about major and minor arcs. So this is always the minor arc. It's the smaller arc. And it's just the arc between those two secant lines. And then this is the major arc. And there's a relationship between the arcs and the angle. Okay, so we could have two secants. We could also have a secant and a tangent, and we could also have two tangents. The cool thing is that you solve them the exact same way. So here's the relationship. And I have it actually there on the bottom, but we'll write it here too. So we have the circumscribed angle, and you could probably just write angle. So the angle is equal to the major minus the minor arc, and then we divide it by 2. So that is the relationship if we're trying to find the angle or if we're trying to find one of the arcs. So let's do a couple examples. Here we have, again, that same formula. We use this whenever we have an angle that's outside of the circle. Right? So here is a great example of that. We want to identify what's what and plug it into our equation. So we're trying to find the angle, so I'm just going to have it be x. And then we need to major minus the minor. So 155 is the major, it's the bigger of the two, minus the minor, which is 85, over 2. I've had some people mix that up and have it be plus. Again, it's always going to be the difference between the two. All right, so here we could simplify the numerator. I think that gives us 70, if I remember that. Okay, and then we'll divide it by 2, which is 35 degrees. All right, so that's the easier of the two. We don't have to move things to the other side to get x by itself. X is already by itself, so that's really nice. You can go through those really quick. Let's look at B. So now we know the angle. We know that the circumscribed angle is 60, and then we'll do major, which here we could say is x. We don't know it, minus the minor, so minus 57 all over 2. So how do we get x by itself? So we kind of take off those layers. Again, first thing we want to maybe get rid of is that 2. So it's being divided, so the opposite would be to multiply. So we'll multiply both sides by 2. So 120 equals x minus 57. And then we could just add 57 to both sides. And we get x equals 177 degrees. Okay? And then let's do one more example. We'll skip D, but we'll do C. So this one is where we have two tangents. So first one we had a tangent and a secant. This is also a tangent and a secant. Maybe we should do D just for the heck of it, but it's all about the same. But here we have two tangents. And if you have two tangents, there's something special about it, is that this arc is part of that circle. And if we're trying to find the major, what else could we do? If we're trying to find this part, right? Well, we know that a circle adds to 360, so this major arc has to be 360 minus 110. And really we can only do that if we have two tangents. If we had something like this, we can't really do, 360 minus 85. I mean, you could do that, but that doesn't give you the major arc. That would give you this arc, which isn't what we're looking for. So, but if we have two tangents, great, we can do that. So here we'd get 250. So now we have the major, we have the minor, and we can find the angles. So x is equal to, 250 minus 110 divided by 2. And that would give us 140 over 2, which is 70 degrees. All right, why don't we do D? I don't think we did this in class, but here's just another example. So we have major, or I guess we should say angle is equal to the major minus the minor over 2. So that would be 100 over 2, or 50. Okay, so this is a secant, but again, we kind of do the exact same thing. All right, so let's talk about this one. What you notice that's maybe a little different is now we have like expressions. We have variables that we need to solve for. Okay, so we set it up the same way. Would say, well, our angle is 40 is equal to the major. So the major is 38x minus 2. And then we want to subtract that from the minor, which is 70, all over 2. Same sort of thing that we did before. We would maybe, before we can like maybe combine like terms or things like getting x by itself, we'd probably need to get rid of that denominator. So we can multiply both sides by 2, get 80 is equal to 38x. We could combine these two already, so that would give us negative 72. And then we just need to get x by itself, so we'd add 72. So that's 152 equals 38x. And then divide by 38. And that should give us, I think, x equals, I think it's 4. Okay, I don't have my calculator with me, but I think we can double check and make sure. So that would be our answer. If there's a couple in the homework where they ask you to find maybe the arc. So if you needed to, we could plug that in here and we could find the arc. This problem, it just says solve for x. So, but just be aware. Okay, F is about the same. If you have any questions, let me know. Again, this is two tangents, so we can do 360 minus 255. So I think that's like 105. And then we'll just do the same sort of thing. I guess we could write it out. We still have time, right? So 255 minus 105 over 2. Okay. I had some people ask about if we, and this probably don't have to do it, but like if we had x's on this side or whatever, if we multiply both sides by 2, it is important that you multiply the 2 by both of the terms, okay? Here you don't have to because we all have just numbers on this side, so we could evaluate that. That would be what, 150 over 2, so that would be 75. And we could add 5, which gives you 80. And then divide by 10 would give us x equals 8. Okay, so that's about it. On your homework, there are a couple problems that you, I'll just leave it to that. If you have any questions, let me know. There are a few problems that are a review. Please make sure that you can get those. If you have questions, please come and talk to me. For this year, if this is 2022, these are the problems you don't have to do. So if you have questions, please let me know and we'll see you later.